Okay, first let's go through these two big problems I've sent to you. We wrote molecular equation, complete ionic and net ionic before. Now let's do some calculations. So we have 13.065 grams of barium nitrate and 11.0 grams of lithium sulfate. We need to calculate theoretical yield. So reaction is balanced. It is 1:1 mole-to-mole ratio. We need mass of precipitate. So we need molar masses of these three compounds: barium nitrate, lithium sulfate, and barium sulfate. Because barium sulfate solid is our precipitate. So barium NO3 2 has molar mass 261.3 grams per mole. Lithium sulfate 110 grams per mole, and barium sulfate 233.4 grams per mole. Now we should assume this is our limiting reactant, barium nitrate, and we start with it. 13.065 grams of barium nitrate, 1 mole, to 61.3 grams, and 1 mole of barium nitrate can produce 1 mole of barium sulfate, and 1 mole of barium sulfate is 233.4 grams. So this is going to be theoretical yield of barium nitrate in grams.
I got 11.67, and I guess that would be, yeah, that'd be 4 significant figures.
Yeah, so far we can leave four significant figures. Now we'll set up the same calculation for second reactant, lithium sulfate. 11.0 grams of lithium sulfate, 1 mole, is, where was it? 110 grams. 1 mole of lithium sulfate can produce 1 mole of barium sulfate, and 1 mole of barium sulfate is 233.4 grams. 23.3,
yes.
yeah, grams. So this is smaller, right? So this is our theoretical yield. And it shows us that barium nitrate is limiting reactant. So we know theoretical yield, and we know actual yield was 8.85 grams. So we can calculate percent yield. equals actual yield. What did I say? 8.85. 8.85 grams divided by theoretical yield 11.67 grams times 100%, and I got 75.8%. Okay, that's it. Now, second problem. How many liters can be formed at STP? And we have sodium carbonate and phosphoric acid. So first we need to write molecular, complete ionic, and net ionic equations. Sodium carbonate, Na2CO3, plus phosphoric acid. Do you remember formula? H3PO4. And so we need to combine sodium with phosphate. Sodium +1, phosphate -3, so it's going to be Na3PO4 plus, when we combine hydrogen with carbonate, theoretically we should get carbonic acid, H2CO3, but we remember it is very unstable, so it gives us liquid water and carbon dioxide gas. Okay, now we need to balance it. 2 and 3, so we should do 2, 3, 2 here and 3 here for sodium. Now we have 2 phosphates, so I put 2 here. 2H3, so I need 3H2. 3 carbons, I'm putting 3 here. And now let's check oxygen. 3 times 3, 9, plus 8, 17. 2 times 4. Oh no, I don't need to include this. This is balanced as a phosphate. Okay, 3 times 3, 9. 3 and 3 times 2, 6. 6 and 3, 9. Balanced. Okay, so here we have different, not 1 to 1. We have 3 moles, 2 moles, 2 moles, 3 moles, and 3 moles of CO2. Now let's write what complete and net ionic. So we are breaking all aqueous. This is also aqueous, and we want to break liquid and gas. 3 Na2, so 6 Na plus, plus 3 applies to both CO3 2 minus, plus 2 times 3, 6 H plus, plus 2 PO4 3 minus. We also break this 6 Na plus, plus 2 PO4 3 minus, plus 3 water liquid. We don't break water, plus 3 CO2 gas. So we can cancel 6 Na plus and what, 2 PO4 3 minus. And what is left gives us net ionic. 6H plus, plus 3 CO2 2 minus, 3H2O liquid, plus 3 CO2 gas. And we can reduce, we can divide everything by 3. So 2H plus CO2 2 minus water liquid plus CO2 gas. Okay, so reactions are finished. Now let's do calculations. Uh, we are interested in calculating volume of carbon dioxide gas at standard temperature pressure. And we know that at standard temperature pressure, 1 mole of any gas has volume 22.4 liters. And we have two reactants in grams, 3.18 sodium carbonate, 190.96 phosphoric acid. So we need molar masses of sodium carbonate is 106 grams per mole and phosphoric acid 98 grams per mole. Now, the same way, we start with sodium carbonate. So we had 3.18 grams of Na2CO3 and 1 mole one or 6 grams and 3 moles of Na2CO3 can produce 3 moles of carbon dioxide. And let's stop here and compare just number of moles, and then we'll convert moles into liters, not into grams. Now let's do the same for our second reactant. We have 1.96 grams of H3PO4, converting it to moles. 98 grams and 2 moles of H3PO4 can produce 3 moles of CO2. Okay, now let's calculate these two numbers. 3 and 3 cancelled.
I got 0.03.
Moles here and the same number here,
Same thing.
the same thing. So can we determine which is limiting? They are both limiting. They will both react completely. We have exactly equivalent number of moles, right? So both reactants will react completely, no excess reactant, and this is theoretical yield for both of them. Okay, so we know we'll get this way or that way, we'll get 0.03 moles of carbon dioxide, and if 1 mole is 22.4 liters, we can calculate its volume. Volume of carbon dioxide, 0.030 moles. And we know that 1 mole of any gas, 22.4 liters. So it's going to be
0.72 or 0.672, sorry.
liters or 672 milliliters. If you like milliliters both, more, it doesn't matter. Okay, oh no, how many liters? Yeah, so we don't need milliliters, we need liters. And now just, for example, we don't use standard temperature pressure. We are somewhere on the Mount Everest. So let's assume pressure equals 0.8 atmospheres and temperature, it should be very cold there, right? And temperature, let's make it negative 13 degrees Celsius. And we need to recalculate this volume. We have the same number of moles, so we don't need molar mass, and we'll use combined gas law. P1 V1 divided by T1 equals P2 V2 divided by T2. So we need to convert this temperature to kelvins. So temperature T2 equals 273 minus 13 to 60 kelvins. And now we can plug it in. So 1 atmosphere initial pressure, 0.6772 liters, volume at STP, 273 standard temperature equals final pressure 0.8 atmospheres, final temperature final temperature 260, and we need to calculate final volume V2. So V2 equals 0.672 times 260 divide by 273 divide by 0.8.
Uh, 0.8.
0.8, just 8.
Yeah, it came out even, just 8.
Okay. And yeah, if we have one significant figure here, we should keep one significant figure, 0.8 liters. So volume will increase a little because pressure drops. When pressure drops, volume should increase. Okay. So remind me, please. Oh, how many this problem you were having trouble with? Carbon, silicon.
Yeah, so it gives me the unbalanced equation SiO2 plus C, and then that's the reactants, and the products are SiC plus CO. And it tells me I have 2.5 moles of SiC.
You will get 2.5 moles, right?
It says how many moles of carbon are needed to make 2.5 moles of
Okay, okay. But
space.
first we need to balance it.
Okay.
Yeah. 2 and only 1 here. So this way it will be balanced if I put 2 here, right? And hide this 2. So now I have to multiply everything by 2 except this one. Uh, no, it won't work. I need to multiply this by 2. And now I have 2 and 1, 3 carbons. So I change it to 3. Okay, now let's check. 1 silicon, 2 oxygens, 2 oxygens, 3 carbons, 1 plus 2, 3 carbons. Okay. So when we have 1 mole of silicon carbide, we need 3 moles of carbon to produce it. When we have 2.5, we need X. So 2.5 moles of silicon carbide we have, and we know that to form 1 mole, we need 3 moles of carbon. So it's going to be 7.5 moles of carbon. I think your mistake was that you didn't balance this equation, right?
And that could be possible. Let me see what other questions I missed because I missed like all of those. So maybe I just thought that they were already balanced, I guess, or I overlooked it or something.
Yeah, but it was underlined, unbalanced reaction. Yeah.
And then I kind of want to talk about that last example we did. A few questions that I just want to make sure I understand. So for the well, my first question would be, how do